Hello everybody and welcome to your video notes on Learning Target 7.1, the Extends level. And here we're just doing some vector addition, so get excited. The Learning Target's words, or the words that describe the Learning Target are, I can use vector components to determine the resultant of two or more angled vectors. The thing that you have to be aware for this is down here. When you're adding vectors, you must keep the x components and y components separate. If you have something that's at an angle like this, and let's say you've got 20 newtons of force there, and then you've got another, let's say we've got another one that's at this angle like this. Well, let's make that a little bit more angled. Let's say like this, and this is 25 newtons. You cannot just do 20 newtons plus 25 newtons equals 45 newtons. That does not work. Instead, you have to think about it as that the x direction, these two can only go together, and then the y direction. So if I use a different color for that, these can go together and these can go together, but the 20 plus 25, it just doesn't work out like that because you have some that's in the x direction and some that's in the y direction. You have to instead break it up. In order to do this, there are some steps that I'm going to have you write down in order to help you organize your thoughts. Step 0, you're going to draw each vector. Okay, and I want you to do that because sometimes, you know, you might have one going this way, you might have one going like this, one like this. Excuse me. And you're going to want to make sure that your angles are drawn correctly as well. So that's what your first step is. Then you are going to split everything into the x and y components. Only if needed. If you have something that's just, you know, straight east or straight to the right, you obviously don't need to break that into a y component because it only has an x component. Step 2, you're going to add all of the x components separately from the y components. Okay, so in the end, you're going to have a list of x components and y components, and you've got like 32.3, you've got 4, you've got 60, negative 60, and then on the y direction, you might have like 2.3, maybe negative 2.3, 56, and 14. Okay, so then you just add these together, and then go from there. And then the last thing you do, you're going to combine the new x and y components with the Pythagorean theorem. then you'd have your answer. So in the end, let's get rid of that. We have these 3 things that you're going to do. Well, really 4. Drawing the vector. When you split everything into the x and y components, if it's pointing to the left, it's going to be negative. And if it's pointing down, it's going to be negative. Okay? If it's pointing, let's do a different color. If it's pointing up or to the right, then it's going to be positive. Okay? All right, let's come over here and we're going to do this example. Go ahead and pause if you need to write this down. Otherwise, I'm going to go ahead and get started. So we're going to add the following vectors to determine the magnitude of the resultant. So we just need to know the size. We do not need to know the angle. So it looks like we have a 20 meter Newton, and then it says an angle, a 50 meter, and then 30 meter. So we have 3 vectors. The first vector, it says 20 meters at 30 degrees west of north. So if we think about a compass and the cardinal directions, we've got north, south, east, and west. I can draw that better. South, west, east, north. There we go. So these angles are going to be given to you like this, west of north. So the of part, that's where you would start. So I've got 20 meters at 30 degrees west of north. So if we look over here at this compass, if it was just north, it would just say north. But it's going to say that we're slightly west of that by 30 degrees. So we're going to have an angle that is in between west and north. That's the way you can think about it. So I'm going to have a vector that's like this, and then this angle right here is going to be my 30 degrees, because over here is west and over here is north, and we went 30 degrees westward of north. Okay, sorry if everything glitched just a little bit. I had a problem with the recording. Not sure where it was, but if this is where our angle is, so this would be our angle here, or 30 degrees, because if this side is west and this side is north, we went 30 degrees in the west direction of the straight north direction. Okay, and then the second one, we have 50 meters at 10 degrees north of east. So remember the of is where if we were going straight east, it would be just like that, but it's not that. We know that this is east, and we're just going to go slightly north of that. So north is straight up, so then we're going to go just at an angle like this. So we are going in the north direction starting at east. This would be your 10 degrees, just north of east. Okay, and then the third angle, let's go over here maybe, is just 30 meters south. South is that way, we don't have to go in any other direction, and to be 30 meters. Okay, so then we're going to start over at the first vector, and we're going to break that into x and y components, which, if you have been following your video notes for the earlier stuff, shouldn't be too difficult. This is going to be the y component, and then this one will be the x component. And then remember, our angle is right here. And so then we're just going to use sine, cosine, or tangent to figure out, which. Okay, once again, apologies for the jump. I don't know what's going on with my computer. But wherever I was, I believe I was talking something about we're going to use sine, cosine, and tangent to find, or sine, cosine, or tangent to find the x and y components. So for the x direction, this one is opposite from the angle, which normally the one that's opposite is sine, but in this case, since we have things arranged a little bit differently, the opposite, we're going to use sine because of the SOHCAHTOA. The hypotenuse is the 20 meters, and so then we have the sine of 20 meters equals the x side over the 20, go back, this is the 30 degrees over the 20 meters, multiply both sides by 20, and then we end up with an answer of, wow, that was pretty nice. The x direction would be just 10 meters. And if we go to the y direction now, we're going to deal with the adjacent side. So for that one, it would be cosine, because that's ka in the SOHCAHTOA. So we'd have the cosine of 30 degrees equals the y side over hypotenuse, which is be 20 meters. Multiply both sides by 20 meters, and we end up with 17.3 meters. So for our first component, we've got in the x direction 10 meters, in the y direction 17.3. And then we're going to come over here to the second one, and we are going to do the same thing. Let's see, in the x direction I did blue. Y direction I did green, so I'm going to stick to the same color scheme for that. So we've got the x direction, and we've got the y direction. Okay, so then we're just going to calculate our components once again. Apologies for the jump. My computer's being all glitchy. I apologize. That's the y direction. So now we have to use sine, cosine, or tangent to find our answer. Let's see, I've got this one, so I'm going to use that for the y direction. The y side is opposite from the angle, so we're going to use sine because sine has to do with the opposite side, unlike the first example. So we've got the sine of the angle, which is 10 degrees, equals the opposite side, which is the y, over the hypotenuse, which is 50 meters. That's what was given to us, or 50 meters. Multiply both sides by 50 meters, and we get our, this crosses out, and then in the y direction we get 8.68 meters. I'm going to switch my colors over to blue. The x direction, this one's going to be cosine because this side's the adjacent side to the angle. So we've got the cosine of 10 degrees equals the adjacent side, which is x, over the hypotenuse, 50 meters. Solve this for x by multiplying both sides by 50 meters. And we get 49.2 meters. And then lastly, the third one, no calculation needed. The x component is 0 meters, and